Hi, this is the, I think it's the fourth video in the series on looking at this particular sample specimen paper. This is the calculator version, is higher tier. Now this particular playlist started off fairly simple, but towards the end it's getting a little bit more challenging, and we're now going to be looking at question 23 onwards. I'm going to aim for this video to be about 20 minutes to 30 minutes or so in length. Please do print off the paper from the link below in the description, have a go at the questions yourself and then compare your solutions. Okay, so let's move on then with question number 23. Now unfortunately there isn't enough room on the video, but basically you can read this for yourself if you have a look at the sample paper and download it. Now basically it spreads over 2 pages, so I'm going to be working on the second page, but I will refer back occasionally to this particular diagram. But it's basically saying that we've got to work out volumes and use that in order to work out the radius, which is the surface area of the water in the cone. So it's actually this radius over here that they're looking for. Okay. They very helpfully give us quite a bit of information in terms of the formulas that we can use. What they say is that the volume of a sphere, now remember in a previous video I said that actually sphere just means ball. In this particular case it's a bowl, okay, it's just a round object. So volume of a sphere is that. 4 over 3 pi r cubed, where r is the radius and the volume of the cone is that. Okay, so let's just have a look at the total volume of the hemisphere, which is the first bowl. Okay, so remember this is the sphere, so whatever we do to this we have to half it. So what I'm going to do is I'm going to put total volume of hemisphere, and I'm actually going to underline that just to remind myself that what I need to do is put in a half 4/3 pi r cubed. Okay, well thankfully with this particular question we've got all the information that we need, because we know the radius of the bowl is actually 6 centimeters, so that's the only unknown. I can just plug that straight in. Okay, now just be very careful with this, because what you end up doing if you're not careful is just making lots and lots of numbers for yourself, and really it's very much better for you to leave this in pi version. So when your calculator calculates, what you should get is 144 pi as the total volume. Okay, now I suggest that you leave it like that, because it's much easier then to work with this. Don't forget pi is the same for pretty much, well, it's not the same, it is the same, it's a big long number, but in most calculators this will be 3.142 so on to about 10 digits. Okay, so it's going to be the same for most people, and it does actually advise on the beginning of the paper, if you haven't got a calculator, use 3.142. So it's absolutely fine to leave it in the value of pi. Okay, so let's just have a look at that. So we've worked out the volume overall of the hemisphere, but we need to also, it tells us that the water fills 2/5 of the volume. Okay, so you mustn't forget to work out the volume of water. Well, the volume of water is going to be 2/5 of 144 pi. Okay, so it's actually going to give you 288 over 5 pi. Okay, and again I suggest you just leave it at that, it'll make your calculations a little bit easier. Okay, so then we've got that water is then poured into the cone. Okay, so we can then use this information to be able to work out the height, beg your pardon, the radius of the water in the cone, because the water volume, which is what we've just worked out as 288 over 5 pi, is going to be equal to the volume of the cone, and it tells you that very helpfully right at the very top, the volume of the cone there. So I can say that's going to be equal to 1/3 pi r squared h. Now at the moment it does look a little bit tricky, but it kind of, these sorts of things kind of work themselves out usually. So what we end up with is that I know the height of this is 12. Okay, the radius is what I'm looking for, and I've got a third. So actually I've got a third times h. Well, it's a third times 12, which is going to be 4. So I could, just to put that intermediate step, times 12, well, a third of 12 is 4. So I can actually, all of that I can write as 4 pi r squared. Okay, on the left hand side I've got 288 over 5 pi. Okay, so what I'm going to do is if you want to key this directly into a calculator, just use the fraction key. If you're using a scientific calculator, it's usually up there on the left hand side, and if you plug that in, you should be putting into your calculator 288 over 5 pi divided by 4 pi. Okay, now we could simplify that a little bit, but for the sake of this particular video I think it's easier for you just to go ahead and do that. If you do that, what we're doing is we're taking this 4 pi and we're dividing through both sides, so it leaves me on the right hand side with r squared. Okay, and when I calculate that out, I get 14.4 equals r squared. So if I then square root it, I get r equals 3.795 centimetres. So the value of r to one decimal place is going to be 3.8 centimetres to 1 dp. Okay, I hope that's all right for you. It is a fairly straightforward question. It just takes a little bit of time to make sure that you kind of set everything up correctly. And as I say, my best advice is don't let the calculator multiply out by pi. Just leave it in there and then figure it out. Just leave it like that and you should be absolutely fine with these things. Okay, I hope that's been all right. Let's move on then to question number 24. And this is a little bit tricky, this one, although it is only 2 marks. It does kind of go on a little bit. I'm afraid towards the end of this paper the questions are a little bit more challenging. Okay, but what it says is you've got a big wheel, it's got a radius of 15 and it turns. Okay, lowest point of the wheel is always 2 meters above the horizontal ground. Okay, and then it says you need to show that h equals 17 minus 15 cosine x. Okay, well I think it's good practice that every time you see sort of cosine, something like that, just write SohCahToa. Okay, because if you do that, it reminds you that when we're talking about cosine, we're actually talking about the adjacent and the hypotenuse. Okay, so let's just have a look at that for a moment. If we look at this, we've got a right angle triangle. Okay, so that's my right angle triangle in there, and I could write, if I wanted to, that the cosine of x equals the adjacent, which is actually going to be this bit here, and then the hypotenuse, which is 15. Okay, I hope you can see that. So I've got adjacent divided by the hypotenuse of 15. Okay, so I can then say that if I want to work out the adjacent, it's going to be 15 times cosine of x, and that equals the adjacent. Okay, so don't forget the adjacent is part of the overall height of this particular one, and it's showing that height equals. Okay, so the height is going to be 17, because 15 here is the radius. This 15 will drop down to here, so this radius here is 15 plus this 2, so actually the height is going to be 17. Okay, and if you want me to put in there that that's made up of 15 radius plus 2 above ground. Okay, so that's that 17. Okay, and then I'm going to, in order to work out the value of h, which is this bit here, I need to take away this value of the adjacent, which we've already worked out as being minus 15 cosine x, okay? And that is the value of the adjacent. Okay, I hope that's okay for you. It just takes a little bit of explaining, a little bit of working through, but essentially that's what they're getting at when you actually show that these types of questions. Okay, so let's move on then to part B of this question, and it asks you to work out the horizontal height above the ground, which is part D. Okay, so again, let's have a look at that. So what I can do if I want is I can draw in a right angle triangle. Okay, right angle triangle in there. Now the reason I can do that is because if I know that this hypotenuse is 15, I also can work out this angle here, because this angle is a right angle and then overall is 120 degrees. So actually in here I can say that this bit of it is 30 degrees. So that's that angle there. Okay, so what I've got then is a rather neat trigonometric problem using again SohCahToa. Okay, so what I can say, if I'm going to work out the height d above the ground, I can say I'm going to use SohCahToa. Okay, I know this is 30 and I know this is the opposite. Okay, I know this is the hypotenuse. So I'm going to use the sine rule in order to answer this particular question. So what I can say is the sine of 30 degrees equals the opposite, which I don't know, divided by the hypotenuse of 15. So if I multiply that through, I get 15 times the sine of 30 equals the opposite. Plug that into my calculator and I actually get 7.5 equals the opposite. So in other words, this value here is 7.5 meters. Okay, so if that value is 7.5 meters, I then need to add that on. Don't forget, we said before that this overall is 17. So if this overall is 17, the height of D must be 7.5 plus 17, which is 24.5 meters. Okay, so again, a little bit of a tricky application of SohCahToa and trigonometry, but I think it's overly complicated sometimes by putting them in wheels and that sort of stuff. But it's probably a fairly good question, certainly quite challenging. But please do stop the video, have a go at all of these questions for yourself. Okay, so question number 24C, and it says here is a sketch of the graph where for one complete turn of the wheel. Okay, so basically what we're doing is we are taking that wheel around and we're saying P is the highest point on the graph. Okay, well, if P is the highest point on the graph, it's going to be this point here. Okay, so the wheel has kind of gone round from 2 meters. Okay, this is 2 meters, don't forget. So that's that 2 meters here. Okay, and then as it's gone round, this height has increased and increased and increased, which is what's happening here. Okay, and then eventually it gets to the point where this goes all the way around and it gets to that. Well, what's the height when it gets to there? Well, it's going to be the radius, which is 15, plus the distance between O and B, which is 17. So actually the height at P, this particular height here, is going to be 15 plus 17, which means that this must be 32 meters above the ground. Okay, so we're asked to work out the coordinates of point P. Okay, well, if we look at that, then actually that would be 180, because it's actually gone through a half circle, so it's going to be 180 degrees. Okay, so we've gone, as I mentioned before, we've started here, We've plotted the height, all the way around, all the way around, all the way around, all the way around. It gets to there, and at that point it's gone through a half circle, so it's 180 degrees. Now if you wanted to check that, what you could actually do is use the formula. So remember what we said is the formula height equals 17 minus 15 cosine x. Okay, so if we plug that in, we've got height, which is 32, equals 17 minus 15 cosine x. Okay, now what I would do then is I would take this minus 15 cosine x over to the other side, and that would give me 15 cosine x because I want positive numbers. And then I'm going to take this 32 over to this side, so that's going to be 17 minus 32, which is minus 15. Okay, so then I'll divide through by 15, so I'm going to get the cosine of x equals minus 15 over 15. Okay, and if I do that inverse trigonometry, what I'll get then is equal to 180. Okay, so you've kind of almost proven to yourself that that sort of works for you. So the value of the x coordinate is going to be 180, and the value of the y coordinate is going to be 32. Okay, so I hope that's been all right for you. We're going to move on then to an algebra type question, which is, I think, the last but one question in this particular paper. So hopefully we'll be able to finish that within this particular video. Okay, so let's move on then to question 25. Which is a fairly typical kind of completing the square. The problem is we've got this coefficient of 2, which just makes life a little bit more difficult over there. But what I'm going to do is I'm going to take 2 out, okay, and I'm going to work this through. So if I have a look at that, I can say that I'm going to rewrite this bit as rather than 2x squared minus 6x plus 5, okay, I'm going to take that out. I'm going to write it as 2x squared minus 3x plus 5. Okay, well, let's have a look at that for a moment. So the standard form when you're completing the square is to half this and square it. You'll see what I mean, and do have a look at some of the videos in the playlist on completing the square. Okay, so if I have a look at that, what I've done is I've taken this as x, and then I've halved that, so it's x minus 3 over 2, and then all squared. And the object really is we're not changing the value of this particular expression, but what we're doing is we're just rewriting it in a slightly different format. Okay, so if I now just multiply this out, I'm going to have x minus 3 over 2 times x minus 3 over 2. Okay, so let's work that out. Well, I've got x times x is x squared, and then I've got minus 3 over 2x minus 3 over 2x. Well, that's going to be minus 6 over 2x, and if it's 6 over 2, I can write that as minus 3x. And then finally, I've got minus 3 over 2 times minus 3 over 2. Well, that's going to be positive 9 over 4. Okay, so you can see there that you're going to need to have a little bit of experience of dealing with fractions. Okay, so just be very careful about how you do these things, because what I've got is I've got this value of x squared minus 3x, but I've also got this plus 9 over 4. So what I end up with is 2 again, and I'm going to use some big brackets. I've got x minus 3 over 2 squared, but then I need to get rid of this minus this 9 over 4. So I'm going to minus 9 over 4, okay? And then I'm going to finish off my brackets, and that's going to be plus 5. Okay, so let's now have a look at that. Well, I'm going to leave this as it is, but I've got to multiply this out. So basically, if I get rid of the square brackets, I end up with 2 times x minus 3 over 2 squared. But then I've got 2 times minus 9 over 4. Well, 2 times minus 9 over 4 is going to be minus 18 over 4, and that's going to be plus 5. Now, I do appreciate this is a little bit trickier type of completing the square, but if you do have a look on the playlist, there are some examples of how this particularly works. Okay, now I need to be able to, as I mentioned before, work with fractions. So what I'm going to do is I'm going to reduce that, and then I'm also going to put this over the same common denominator. So don't forget, this can be reduced to minus 9 over 2, okay? And then, rather than writing plus 5, I'm going to write plus 10 over 2, because then that will allow me to add those two fractions together, okay? If I do that, then it means I get 2 times x minus 3 over 2 squared, and minus 9 over 2 plus 10 over 2 is plus 1/2. Okay, and that's actually the answer to this extremely complicated question, but hopefully it will give you some idea of how you can work with completing the square. And in this particular case, a equals 2, b equals 3 over 2, which if you like is 1.5, but with these type of questions you need to really keep them as fractions. It's actually much easier to multiply fractions than it is to multiply decimals, and I can hear everybody out there saying no, that's not the case, but it is much easier to work with fractions, and generally speaking a lot of these papers are becoming much more biased towards fractions now anyway. Okay, and c is 1/2. All right, I hope that's okay. Please do print off that solution, kind of work it out for yourself, make sure you're happy, particularly when I get rid of these square brackets. I'm going to leave this bit as it is, there it is, okay, but then I need to not forget that I've got to do 2 times minus 9 over 4. Well, 2 times minus 9 over 4, just for the sake of, just for the video, I can do 2 times 9 over 4. Well, that's going to be 2 times 9 is 18 over 4. If that's a minus, that'll be minus 18 over 4, which is what I've got there. Okay, I hope that's all right. Let's move on then to actually using the answer, this answer, to be able to solve this particular equation. Okay, so we've already worked out that if I write this out as completing the square, I've got 2 and x minus 3 over 2 squared plus 1/2. Now in this particular case now it equals 8.5. Okay, well if it is the case, I can firstly get rid of this plus 1/2 by taking it away from both sides. So I'm going to end up with 2 x minus 3 over 2 squared, and that's going to be equal to 8. Now again, like a lot of these things, it looks a bit scary to begin with, but actually they kind of work out, because I can divide both sides now by 2. So I could write x minus 3 over 2 squared equals 4. Okay, so then it would be a case of saying, well, actually what I'm going to do is I'm going to square root both sides, because I need to get rid of this squared here. So I could write x minus 3 over 2 equals the square root of 4, which is 2. Now don't forget that the square root of any number is a plus or a minus. Okay, so I can then, I've got this value of x here. I need to get rid of this fraction and take it over here. So what I'm going to do is I'm going to write x equals 2 plus 3 over 2, or x equals 2 minus 3 over 2. Now it might be easier for you to think about 3 over 2 as 1.5. Okay, so 2 plus 1.5 is 3.5. So x equals 3.5, and that's one of my answers. And 2 minus 1.5, well, that's going to be, yeah, 2 minus 1.5. I got that right. So 2, oh, beg your pardon. That's going to be minus 2, beg your pardon, minus 2 minus, this is minus 2 here, and this is going to be plus 2 here. Okay, so minus 2 minus a half. Okay, so it's going to be plus 2 plus 3.5. No, yeah, and it's going to be minus 2 minus 3.5. So 2 plus 3.5 is going to be, that's 3.5, and that's going to be minus 2 minus 3.5. Minus 2 plus 3.5. I knew I'd get that right eventually. So that's going to be, beg your pardon, when you move this over to the other side, it's going to become a plus. So that should be plus 3 over 2. So it's minus 2 plus 3 over 2 is going to be minus 0.5. Okay, you can tell it's getting towards the end of the paper here because we have to make sure we keep checking every single question. So I'm sorry about that. Just before I get a few comments on the video, I do apologise. So this is going to be plus 2. This one here, and this one here is minus 2. And then when you take this 3 over 2 over to the other side, that's going to become a plus there. So minus 2 plus 1.5 is going to be minus 0.5. Okay, I hope that's all right for you. Let's move on to the very last question in this particular paper, which is actually not too bad. It's fairly straightforward-ish. Okay, the main reason, the main thing with it is what they say is that the larger box takes 44% more card to make the larger box. So the larger box, and that equals 1.44 the smaller box. Okay, so in other words, 1.44 is because boxes are made up of nets, okay, which is a function of areas. So actually this 1.44 equals the area scale factor. Okay, so it's the amount of cardboard that's being used to make that is 44% bigger than the smaller box, which is also the area scale factor. So in other words, we can say that 1.44 equals k squared. So remember the scale factor is k, but an area scale factor is k squared. Okay, so to work out the linear scale factor, it's the root of 1.44. which is going to be 1.2 equals k. Okay, and then all we do is we say if we want the height of the larger box, we would do the height is going to be 32 multiplied by 1.2, which is going to be 38.4. So actually the height of the larger box is 38.4 centimetres. Okay, and that deals with the end of this particular rather long and rather difficult paper. So I hope it's been successful to you. Please do add a comment below, subscribe to the channel, like the video. I'll always come back to you. There's quite a few playlists on this particular channel, so if you're not sure about anything, let me know and I'll see if I can find a playlist that will be appropriate to give you a little bit more practice. I'll look forward to seeing you in the next series of videos where we'll probably take a bit of a breather and have a go at some other papers, maybe some foundation papers. But in the meantime, please do subscribe and I'll look forward to seeing you inside the next video.